So let me introduce you Jon Pretty with the first talk. The program for today is roughly 1 hour for Rapture I, roughly 1 hour for Apache Spark, and then we will have 15 minutes roughly for a Scala quiz for a free ticket to Scala I/O conference, which takes place in 2 weeks in Paris. So you will have an opportunity to win a free ticket tonight. And then we'll go to the pub, whoever voted yes at the RSVP, to get some drink, which will be sponsored by Adventura. Thank you, Lasta.
Okay, thank you.
Thank you.
Thank you. So it's good to be here in Prague and to see so many of you here. This is actually the second talk of a tour I'm doing around Switzerland, Germany, Czech Republic, Poland, and Belgium over the next, I guess, 2 or 3 weeks. Now, being the second one, there's a positive and a negative from that. The positive is that I'm still excited about it, and I haven't done this talk 10 times before, so I'm still excited. The negative is that I will sometimes be surprised by which slides appear next, and there are over 50 slides here, which will go quite quickly. So apologies if I'm confused by what I see on the screen, but I will try and talk you through it. So I'm going to talking about Rapture, which started off as an I/O library. So it used to be called Rapture I/O. Now it's more just Rapture because there's a JSON library, there's an XML library, there's a cryptography library, and I'll show you examples of that later. But the way I'm going to do it is by demonstrating one-liners. So I'm going to go through 50 or more single lines of code, which will hopefully be intuitive, and you'll be able to see in a very concise form what Rapture is doing, and hopefully you'll appreciate the syntax. It's designed to be very expressive. So I'm going to jump straight in, and oh dear. Okay, right, we've got some text. So this is a resource. This is an HTTP resource in Rapture. This is how you would write this. Can you all see the pointer? Okay, there. Yeah. So at the top, I'll have some code, and then as if you type that into the REPL, this is what the output would be at the bottom. It's the same for every slide. So this is a resource representing an HTTP URL. Now that's been in Rapture for 3 years or so. If you wanted a file-based URL, use exactly the same style. So this is like the scheme, and this is the path. So you've got this mini DSL, but this is actually the old way of doing things. This is how you did things in Scala 2.9. There's a new way. So now you can just write this. You can write URI. Who's seen string contexts in Scala, or string interpolation? So string interpolation, you've seen a string with normally a lowercase s in front of it, or maybe raw. So you can have raw strings as well as standard. So this is a URI. You don't actually get a string at all. You get, in this case, an HTTP URL. So this actually invokes a macro which reads the contents of this, works out what it is. So it looks at interprets at compile time, crucially. It interprets the scheme. It knows that HTTP corresponds to an HTTP URL, and it gives you this object here, provided all this is known at compile time. And likewise, we can do the same thing with file. So the return type is different. The return type depends basically on the contents of this string. So this is a really neat way of defining a resource. So when I say resource, I'm being deliberately very vague. There's no trait called resource in Rapture. Something is a resource by virtue of having capabilities that can be done with it. So for example, when I say capability, I mean like being able to read something. So you can read an HTTP URL, you can read a file URL. You can write to a file, but you can't write to an HTTP. I mean, you could put data, for example, but there's no standard way of necessarily writing. So reading, writing, checking the size of something, navigating, these are all capabilities, and capabilities operate on resources. By the way, please do shout out with questions. I'm very likely to forget things when I'm going through this, so if I haven't explained something, just shout out, put your hand up, or just let me know in some other way, and I'll happily explain. So those examples you saw before work fine if you know what the string is in advance, or if you know what the URI will be in advance at compile time. If it comes from user input, then you don't know. You don't know whether it's going to be, you don't know what the content of the string is. So the compiler can't work out whether it's going to be HTTP or file or HTTPS or FTP or anything else. So in the more general case where you don't know, we have to use this. We parse it using the HTTP object, and we get the same thing. So I mentioned capabilities. Slurp, or slurpability, if you like, is a capability. So something can be slurped. A resource can be slurped if it's readable. So I said before that files are readable, so we can slurp the contents. And we specify a type here. So we're going to slurp bytes. We're going to slurp 1 byte at a time. I mean, it's more efficient behind the scenes, but byte is the unit of data that we're reading in. And if we slurp in bytes, we get this thing of type bytes. This bytes is a type in Rapture. Think of it as a nice wrapper around an array of bytes. So array of bytes has various issues in that toString doesn't display anything particularly useful. It displays a heap reference, and it's mutable, and we don't want that generally. So bytes is a new type introduced by Rapture that will give you the contents, and it has a nice toString method that displays hex. So we can slurp bytes. Let's try and slurp characters instead. Well, there's a problem here, so I'll read out the error you get. We cannot find implicit reader for file URL resources. File URL resources can only be read if a reader implicit exists within scope. Now that maybe doesn't make much sense, so I'll carry on. Note that if you're working with character data, you'll require an implicit character encoding. And then it gives a couple of examples: import encodings.system or import encodings.utf8. So this is a custom error message that you get when you're working with Rapture, which is designed to be as instructive as possible, because this is the trap you can fall into. You could easily assume that it's really easy to slurp characters. But unlike Java, unlike many other I/O libraries, Rapture doesn't assume that there's a particular character encoding. It would be easy to assume that everything's working in UTF-8, where everything uses the system encoding, and that's what Java will do. But the problem is, if you've written some code, it works fine on your local machine, which has the character encoding ISO 88591, and then you deploy that same code to the server, which doesn't have ISO 88591. It has UTF-8 or UTF-16 or something as its default encoding. Your software will work differently, and there's no protection against that in Java. So Rapture forces you, it sees it as a good practice to require that you specify the encoding if you're going to use encodings, only if you need to. And we do that with an import. So we say import encodings.utf8. So that's the line we have to include. And then whether this code runs on our local machine or on a server or anywhere else, it's not relying on some subtle configuration issue with the server. And if we do the same thing, slurp characters from this HTTP URL. And it's the same if you want to slurp from a file or an HTTP URL, exactly the same command. So it's designed to be very uniform, whether you're dealing with FTP, even the class path, you can slurp the class path as bytes. But we're going to slurp this file, which is on the Rapture I website, which is just some sample JSON. And we get back this string here. So this is the start of some JSON representing the candidates from the last US presidential election. It's just a string at the moment, nothing fancy. But there's another module in Rapture, which is the JSON module, which allows us to parse a string and interpret it as something more structured than a string. So if we parse the JSON we slurped before, we get this. We get something of type JSON. So the JSON type represents some JSON. It might be an array, it might be an object, might be a string or an int or a null even. It's kind of dynamic. Think of it as a clever wrapper around any. So in the most recent release, which I released version 1.0 of Rapture JSON about a week ago, we can actually directly parse straight from a URI, as long as that's readable. If it's not readable, then we can't do it. But anything that's readable can be slurped as a string, and we can parse it. So this is effectively doing the same thing in 4 lines. Now this JSON type, I'm calling a method called candidates on that. Now this probably looks a bit odd, because why would I have a method called candidates on my JSON type? Candidates is very specific to this particular JSON. It wouldn't make sense for me to include it in the standard JSON type. What this is doing, this is actually using the dynamic trait. So who's seen dynamic in Scala? So not that many of you. Okay, it's not used that heavily. I don't know of any other libraries that are using it that much. What dynamic allows you to do is call dot and some method name on a thing of type dynamic, so JSON inherits from dynamic, and that will be converted into a method call to select dynamic with a string of that method name. So the idea is that the method access, the dereferencing, looks like it's accessing a method, but that method doesn't need to exist. If the method does exist, then it will just call the method, but if it doesn't, it will fall back to this alternative, which is to call select dynamic with a string of the method name. And we can do this with any value in JSON. So here I'm accessing the candidates, and we get a value back which happens to be the array that was inside that candidates inside the JSON that we passed. And if you've got an array, we can get the first element. So we just apply 0 to it. And we get this here, and then we can take it further. We can call .name. This is again using the dynamic. Every time we're getting JSON back. Now this happens to be a string. We can see this as a string. But we only know that at runtime. So the compiler has no idea that this is accessing a string. So we have to tell it. We have to assume that it's a string. So the as method takes a type, and it will pull out a string from the JSON. So it will take you from the dynamic world of JSON, the JSON type, into the static world of Scala. And you have to make that jump at some point. The jump is where errors will happen. It's the only place they'll happen. So if I were to call like json.candidates 0.foo, there's no foo method. It won't complain until you until you call as and specify a type, and it'll say missing value. So you don't have to handle errors at every single point where there might be a failure. You handle them once at the transition from dynamic to the static world. And once we've got a string here, we can do all the things we would normally do with a string. Does that make sense? Yeah? Please shout out if anything doesn't. Likewise, we can take the age as an int, so we can specify any type we like here, as long as it knows how to extract that thing. And it knows how to extract strings, ints, booleans, all the primitives that make sense in the context of JSON. And I'll show you some other things it can extract as well. Now, given that we've got a name and we've got an age inside an object, so the object you saw before had a name, age, I think it was 51. what we can do is we can define a case class that contains both of those things. So it's got a name, which is a string, and an age, which is an int. And we can just say, get the whole candidate out in one go. And we get an instance of a case class. So by virtue of all the parameters of the candidate case class themselves being extractable, so strings are extractable, ints are extractable, therefore we can extract the whole case class, the whole candidate. Now, I'm going to take a brief deviation from extracting stuff to talking about how errors are handled. So this is a line you might have at the start of your code in a Rapture application. Import modes.return try. Now, modes are quite a fundamental aspect to the way you would choose to work with Rapture. And I introduced them because someone asked me a question at a conference in London about 3 years ago. And they said, how do you deal with exceptions? And I said, well, if an exception gets thrown, it gets thrown. Deal with it. And the guy who asked the question sort of stared at me, and as if to say, that's a completely unacceptable answer. Why don't you return either, or return try or something? And I thought about it, and I thought, well, yeah, a lot of the time you do want to return try, but sometimes you want to return either, so where the right-hand side might be the success case and the left-hand side is the failure case. But often you genuinely do want the exception to be thrown. Like if you're working in the REPL, you don't want the hassle of having to extract something from a try or from an either every single time you want to get at the value. You just want the value straight there. If an exception's thrown, fine, you see a stack trace and you deal with it. So what I needed was something that was more flexible than that supported multiple possible return types. And I came up with this concept of modes, and they're a bit magic in that it would take me at least 15 minutes, probably half an hour to explain them in detail. But they do work surprisingly well. I was surprised at how well they solved this particular problem. So in Rapture, what you do, if you want to handle exceptions in a particular way, you just import one thing at the start of your file, which is modes. Well, if you want to return try, you import modes.return try. And every method that might fail, so methods that might fail that you've seen so far, parse, JSON.parse, that could fail if it sees some invalid JSON. Slurping could fail if the file is missing or if the network's down. These are all what I call fallible methods, and fallible methods will be dealt with according to the whatever mode is in scope. So, given that I've imported return try here, this call to as, this is a fallible method, because we don't know at compile time whether candidates exist, we don't know whether it's an array, and we don't know whether it has the first element. All of these things could go wrong, and they go wrong at the point where you call as. Additionally, because we're extracting a candidate, we need that to be an object, we need there to be an age and a name inside there. All of these things could fail. So this is a fallible method, as is a fallible method, and therefore, because modes.return try is in scope, we get a try back instead of just a candidate. So when you saw this code the first time, it just returned a candidate. That's the default. The default is to throw an exception. With modes.return try, it will return a try, and it turns out this case is successful. So there are other modes. This was kind of a discovery. You can actually return a future for everything you do if you want to. So import modes.return futures. And every fallible method will return instantaneously, and you'll get a future or a promise back, which at some point later will contain the result. But the execution of that method will be dispatched to a fork join queue, in the same way as if you create a future normally. And it's just an import. You just import return futures instead of return try, and then we can call, for example, slurp we get a feature back immediately. It's not been fulfilled yet, and that is a promise. That's the toString method on a promise. And at some point later on, we can check the promise to see if the value is there. Exciting. So that was modes. Modes are available for anything, pretty much any fallible method I show you in Rapture today. So going back to the JSON, we can extract candidates. We've seen that. Now what we were doing before, we were saying JSON.candidates0.as candidate. Well, actually, we want to do all of them at once. So let's try and extract a list of candidates. So we do that, and we get back a list of candidates. And there's two candidates in the election, Barack Obama and Mitt Romney. And this works for collection types, any standard library collection type. So if we wanted to, we could extract a stack. A stack was the, I was looking through the collections for the most obscure example of a collection I could find. There's no problem extracting a stack. That's what you get back. Or even if you wanted a mutable type, so you could extract a hash set. It just works. So we can then define like a case class representing an entire election, or at least the details we've got in this particular JSON sample. Candidates, which is an index sequence of candidates, and year. Now, I don't think you saw the year in the example. It was truncated, but there's a year field as well. Now, remember what I said about case classes. A case class can be extracted from JSON if all of the parameters, or if the types of all the parameters are themselves extractable. And this is checked at compile time. So year, that's easily extractable because it's an int. But also candidates is extractable because we can extract a candidate, and we can, even though candidate is itself a case class, it recurses, and we can extract any collection of that, of any extractable type. So index sequence of candidate is also extractable. And therefore, we can just say JSON, this is the entire parse JSON, .as election, and we get the full thing. Incidentally, you get a vector there rather than an index sequence because vector happens to be the default implementation. Does that all make sense? It's quite nice? Yeah? You like it? Good. So what we've seen so far has been extracting stuff from JSON that's been provided to us. We can also create our own. So we can. I'm always told off whenever I give this slide in America because it's showing that I'm. It's not trying to make a political statement, but this is, for example, some JSON which represents a vote for one of the candidates. I'm not going to say which one, but you can all read. This is another string context. So we can literally write this JSON code inside inside a string as long as we prefix it with JSON, and then that will be passed at compile time, and we'll get a result, which is a type JSON, and that is structured data. We can also put something. We can also put a value inside there. So in the same way that you can substitute expressions into a string context, if you had an S there, you could substitute a value in there, and what that would do is it would call toString on whatever expression is in there, and it would do the whole thing. In the case of JSON, you can substitute values in as long as they're serializable. And generally speaking, if something can be extracted, then it can be serialized as well. It normally works both ways. So an int can be serialized to JSON. A list of any serializable type. Any case class can be serialized, provided all the parameters can be serialized. And in this case, we were actually looking at the election value we passed before when we did JSON.as election. We're getting candidates one, which is remember this was a case class. This was the second element from candidates. We're just putting that straight in there, and it will substitute the appropriate JSON right in place. So, what I've shown you has generally been working with fixed JSON types so far. We often want to change data. So what we're going to do is we're going to specify a mutation. Well, we're not going to mutate it because we like immutable stuff. So what we want to do is append something to an existing JSON value. So vote is of type JSON. And we've got the syntax here, which is meant to be similar to the syntax of mutating a map. So when you mutate a map, you can say like my map plus, and then a pair, and there's the key and the value in that pair. But JSON isn't a map. It's structured data. So although the value, the thing on the right hand side of the pair, is itself a value, the key, or the thing that's equivalent to the key, is kind of like a lens into that JSON. So what I'm going to say is we're going to add the value 2012 to the year, or we're going to add a year field to the vote JSON. And this is what you get back. This is the new part. Yeah, question?
So is it a tuple? Can I put a row between year and 2012?
Yeah, but I think you might need the parentheses.
Okay.
Oh, actually, no, you can't, because the scope of the underscore will then apply to the whole thing.
Okay.
So you could do it if you put parentheses around the year.
Yeah.
But yeah, generally speaking, you could, but due to a technicality, you can't. Yeah, maybe that would be nicer actually if you could do that, but it just needs more brackets. Now this probably looks weird. So I've shown you. You can think of this as this old one as a, where was it? This one back here. You can think of this as a JSON literal, and you can match on a JSON literal in the same way that you can match on a string literal, just by specifying case, then some JSON, and then this is the specification for what you're matching on. So what this is saying is, I've got this vote here, it's the same vote from the previous slide, and I'm going to try and match that JSON against my specification for some JSON here. And I want to see, if it's going to match, I want to see an object, so this open brace here. I want to see a vote key inside that object. I want that to be an object with a name, and I need some value associated with the field name. And if I've got all that, then that will match. And we can then say voted for C. C is the value we're extracting from that JSON we've matched on. Now remember, the compiler doesn't know what this is JSON. The compiler doesn't know what type it is. So we have to specify, as we always do with JSON, with a type of JSON, we have to specify what type we're going to understand that thing as. So C is a type JSON. We need to move from the dynamic world into the static world and specify the type. But if we do, we can say voted for, and then again, this is not making a political statement at all, but we can extract a value like that. So this is kind of useful if you've got maybe a very big JSON structure with 2 or 3 things you want to extract from it. You just specify the kind of path into those things. Vote, name, and then the values, the identifiers you want to bind those things to when you do the extraction, and it'll match or it won't match. You can do several at the same time. Right. So all the JSON stuff I've shown you so far, you probably assumed that I've written a JSON parser that has its own AST structure and so on. I didn't. I think there are probably other people who are better at writing efficient JSON parsers. If I attempted it, I wouldn't get anywhere near as fast as, say, Jackson, which is one of the quickest. I'd probably be faster than the Scala standard library, JSON parser, but that's been deprecated now. But in order to use JSON, you need to pick your own backend. And this is a system that, so Rapture effectively has pluggable backends. So if we, for example, didn't want any dependencies, if we're using Scala 2.10 and we just wanted to use the standard library, we can import JSON backends.scala.json. It's then got a backend that it can use, and all the stuff I've shown you will work. Alternatively, we could import JSON backends.jackson. Jackson is available as well. So as I go through these, maybe you can all cheer when I mention your favourite JSON parser. So who likes a standard library? No one. Good. Who likes Jackson? Yay! Okay, Jackson's popular. JSON Press, using that. So as I travel around Europe, I'm kind of getting a gauge for how many people use the different backends and how much attention I need to give to each one. So Jackson's popular, JSON Press less so. Lift JSON? Nobody? No? Okay. That's fine. Argonaut? Yay! Okay, so there's one cheer for Argonaut. By the way, whichever backend you're using, you get exactly the same front-end functionality. Everything I've shown you will work, whatever the backend. But there will be different performance characteristics, and sometimes things like serialization order in an object will vary from one to the other. Does anyone know Jon? So Jon is the JSON library written by Eric Osheim, who also wrote Spire. And I'm kind of promoting Jon because it's in many cases faster than Jackson. He's put a lot of time into focusing on the performance of it. The other thing I like about Jon is that when Eric, who's American, says Jon, it's exactly the same as my name. So he calls me Jon Pretty, whereas his library is called Jon. It's the same. So that is another reason why I like it. But the main reason is because it's so fast. So we've seen a lot of immutable JSON. We all like immutable data structures because we're all functional programmers. But sometimes it's convenient to work with mutable data as well. So in the same way that the Scala collections library has lists and it has list buffers, list buffer is kind of the mutable version of a list, Rapture has JSON and JSON buffers. So we can create an empty JSON buffer. We can specify, every time I give this slide, I notice this mistake. This is meant to say equals, not plus equals. And I'm sure every time I finish the presentation, I go and fix it. Now, for some reason, it doesn't get fixed. So either I'm fixing something else.
Maybe it's immutable.
maybe my presentation is immutable. I need to take a copy, which mutates. Yeah. Sorry, this is meant to say jb.life equals 42. And what that will do is that will mutate the JSON buffer value to include this new life value. We can also just add something deep within the structure without specifying first to add a new object and then add. We can say jb.candidate. Candidate didn't exist before. Democrat didn't exist. This is meant to say equals again. Sorry. And we can throw in a case class instance. You can put anything on the right hand side that is itself serializable. So remember, case classes are provided all the parameters are, and this is the same case class as before, so it's fine. We can add this in. So jb.candidate Democrat, that will modify to mutate our instance of JB to include a new object candidate, and within that the Democratic candidate to contain this value here, which is Hillary Clinton. And having done that, what we can do is we can write that data to a URI. Now, we can put any kind of resource, any kind of Rapture resource on the right-hand side here, provided it's writable. So remember, files are writable, and it uses a lot of type class magic to It's not really magic. I mean, I don't like writing software that's built on magic, because magic runs out and everyone gets confused. So I tend to avoid macros if I can. Macros are magic, and I try and avoid them if I can. But it uses type classes to know whether, for example, a file URL is writable. And provided the type class is there, it will allow you to write that contents to this file, and that will give you a summary. So you'll notice that you get a value returned here. What we could have done, is just return unit. I mean, often when you write something, you assume it worked, and if you get a unit value, the empty parentheses back, then you can assume it worked. But it's not very functional. It's not really a functional programming style. So what Rapture will do is it will give you a summary, which is all the information in general that it knows about the operation. In this case, it knows that it ended up writing 85 bytes to that particular file. So if we want to look at this, we can. If we don't care, we can ignore that value. We've also got a copy to method. Now this is interesting because it's very similar to write to. So we can write from anything that's readable to anything that's writable. Now files are readable and files are writable, but a really bad way of copying files is to read the entire file into memory, into your heap, and then to write it out again. That's a bad way of doing a copy. If you happen to know that both of them are on a file system, both those files or both those resources are on the same system, what we'd like to do is just say to the file system, well, take a copy of that. And the file system will do a constant time operation, which will probably add some kind of symlink or some kind of hard link to the file system, which represents the copy, and it's very quick and doesn't involve lots of memory being shuffled around. So this copy-to method knows, because at compile time it knows that this one's a file and this one's a file, it knows that it can do that. So we use the quick way. And the summary we get at the end, we get a copy summary, which says file system copy. It's distinct from a streamed copy. It's the same amount of data, but it hasn't actually streamed it through heap first. If we wanted to copy from an HTTP URL, this is called downloading, where you copy from a resource on the internet, an HTTP resource, to a file. This is typed as HTTP URL. This one's typed as file URL. If you do a copy in that case, it will have to stream it. There's no other way of doing it. So you might have noticed that these one-liners are actually split, filling up 2 lines now. I'm stretching the definition of a one-liner a little bit, but we can have a class path. What it says over here is it's just class and a close quote. Copy to. Now we can write to, if you want to, we can write to Amazon S3. You need to have the right type classes in scope in order to do that. But the class paths are readable. You can always read from the class path. S3 is writable. Provided you've got credentials and scope and so on. So we can use the copy to method. It works in exactly the same way as copying files, copying files from the web. As long as the first thing's readable, the second thing's writable.
But what about asynchronous copy?
Right. So I don't support asynchronous operations yet, but it's something that could be added. So asynchronous operations, would be quite nice. Asynchronous operations would be considered just another capability. So maybe I need to add a capability called async copy. Now I need to spend some more time looking at asynchronous ways of doing things, because there are a number of different ways, a number of different interfaces that you as the user could interact with the underlying system to specify what you're doing asynchronously. And I haven't yet found a unified approach. I haven't devoted as much time as I want to, so maybe I will think about it some more and I'll come up with something that works in general. But the foundations are there to be able to add new capabilities. If something is async readable and something else is async writable, there's no reason why we couldn't have an async copy method that would perform that copy in the background. Yeah. So I think that's most of the I/O stuff, and you've seen a lot of JSON. There's also cryptography in Rapture. So one of the things I've been trying to do is provide nicer interfaces to all the stuff that's in the Java standard library. I'm wrapping much of the standard, common everyday tools you see in the standard library. So what we can do is we can generate a cryptographic key, and as a type parameter to that generate method, you can specify the type of cryptography you're using. So that can be blowfish, it can be DES, AES, and you get a key back, which knows what kind of key it is. Part of the type is, although it's effectively just bytes, and this is a subclass of the bytes type I showed you earlier. Although it's just bytes, the type system does know a little bit more about where that type came from. And given the key, we can encrypt something. Now we can encrypt anything that we can serialize. So a string can be serialized. What are the conditions under which a string can be serialized? Only if there's an encoding in scope. It won't even attempt to. It will complain that you haven't got an encoding if you try and serialize a string if you haven't specified the encoding. But you can encrypt that with the key we've just generated, and we get some encrypted data. Again, we know it's blowfish because the type system's keeping track of that. We can also display that as base 64, or base 32 if we wanted to, or binary. We just specify a type in here. So this as method will show the particular data in whatever form we want. And this is applicable to any subclass of bytes. So the the third or fourth example where I slurped some bytes, you can say those bytes dot as your encoding scheme. And then having done the encryption, we can go back because we can decrypt. Again, it's just a one-liner. We don't have to specify that it's blowfish we're using here, because the key is itself typed as blowfish. It knows the methods that will decrypt blowfish, and it will check that the encrypted data. So remember, the encrypted data was typed as blowfish as well. If they don't match, then it won't allow you to do it. Oh, one thing I should point out is that once you've decrypted it, you don't know what the data is. You don't know whether it's a string or some JSON or I don't know, a fish. It could be anything. It's just byte data. So we do need to specify what kind of data it is. So we're saying this is a string, and this will work if there's an encoding, but we can then specify the decrypted type. So XML. You all love XML, right? So I've shown you all the JSON stuff, and you're probably quite familiar with JSON. You like JSON, and now I'm showing you XML. It must seem like a bit of an anticlimax. So this idea came about because I was adding the different backends for working with JSON. So I had the Jon and the Scala JSON and the Jackson backends, and I thought, well, it's only really it's working on ASTs. ASTs is completely arbitrary in Rapture. You don't see them; they're wrapped, and when you're parsing stuff, it's just parsing a string. The string can contain anything. So what would happen if I just plugged in an XML backend instead? Would it still work? Well, fundamentally, XML is a bit different from JSON. So JSON is much more uniform. It's a much more uniform recursive structure. XML, for example, it's recursively defined, but it's got attributes as well and other complications. But apart from those differences, it's still structured data with some recursion defined, and it kind of works when I plugged it in. So I thought maybe I'll tweak a few things so that it fits better with the XML data type. And you can do this in the same way that you do with JSON. You can say your XML value is parsing some URI. This kind of just works, and we get an XML type. And we can call, I think I've got an example here. We can call xml.candidates.age.asInt. This is basically exactly the same line, except it said JSON there, as I showed you early on. And that it's operating on this structure instead of the JSON. Yeah, question?
How do you handle namespaces?
Yeah, namespaces. So right now I don't. But I had an idea about how I could possibly handle namespaces. I think namespaces add a huge amount of complexity. So I haven't worked out the exact implementation, but it was actually the morning before I gave my talk in Zurich. I was thinking about this exact problem. How am I going to do namespaces in XML? And I was brushing my teeth. I thought, I can use singleton types and some kind of complicated. It made sense in my head. And I think I've got a solution that will allow you to work with namespaces in a way that doesn't make the syntax so complicated and verbose that it's awkward. Right now I haven't got anything working, but I think there's a solution in there possibly. And that's something I'll be looking at over the next few months. Incidentally, I should probably say that I'm giving these talks around Europe kind of for fun, but I really want to put a lot more time into Rapture and getting the library production ready. The JSON library is production ready now. I'm happy for people to use it in, how should I say, mission critical. Don't use it in a nuclear power station, but like it's safe to use in production as long as the back end you're using is safe. What I want to do is get Rapture. I want to make it feature complete, put more time into it, write better documentation. The last year or so, I've been busy working on a contract, not had enough time. So in August, I decided I was going to quit my job and devote a lot more time to working on this. So I'm between now and the end of the year, maybe January, February, I'm going to be full time on Rapture, and hopefully getting it to a stage where it's good to use in production. So that's kind of a bit of a personal background, but certainly if you want to use Rapture, do. If you have any problems, send me a tweet, send a message to the mailing list. My Twitter handle is up there if you want to follow me. And I will be very responsive because I'm very keen for people to ask questions and identify things that I can make better. So if namespaces is really important, which yeah, maybe it is for some people, then tell me about it and I will maybe prioritize that over other things. So probably even easier than XML is BSON, because it's basically the same structure as JSON. There's a few differences in that you can have different date types and other things. But there's people following me now. BSON, I haven't started work on this yet, but it's going to be quite straightforward when I do, because it'll be very similar to the JSON. And you'll be able to parse a BSON file and it will work in the same way as JSON, except you'll see bytes there instead of JSON content. Right, this is the last slide, and I'm almost on time actually, I think. What I've tried to do is, it's really not one line at all, is it? What I've tried to do is I've tried to combine everything into one big single one-liner that covers everything. So I will. You would never write this code. You would always want to have different intermediate values along the way, but here it is anyway. So I'll explain it step by step. What we're going to do is we're going to use JSON to parse a URI directly. This there's not much. There's only punctuation on the right-hand side of this. We're going to parse this URI. That will then give something of type JSON, and we're going to add a value to JSON. We're going to add the encrypted value, which I'm going to set to the string yes. And then I'm going to actually encrypt the whole lot. So this is encrypting that JSON. We can encrypt JSON because it's serializable. We can convert from JSON into bytes. So this key can encrypt it. And then I'm going to write that output to a file. And that's going to place it in.
It's just interrupted.
Okay. that's going to put that into this file on my hard disk called merge. So in one line, although it's split over several, in one line we're loading some JSON, we're parsing it, we're encrypting it, or we're modifying it, we're encrypting it, and we're writing the resultant JSON straight out to another file. By the way, there's a 1.0 tag because this doesn't work in the other versions, but use version 1.0 of Rapture JSON, and this will work. So that's all I've got. Are there any questions?
I have a question about the modes. How are they implemented? Yeah.
About modes?
Modes.
So what I'm going to do is I'm going to say, have a look for my presentation at the Scala workshop, in which I spend half an hour. Actually, I don't think it was videoed. That's a problem. There are slides available online, but I'll give you a quick summary as well, and you can ask me about it later as well if you're interested. It uses so a mode is resolved by an implicit. The implicit looks for a mode that's in scope, and the implicit is taken by the fallible method. So the fallible method needs a mode in order to run. So we look for example, return try. The definition of a mode includes two things. There is the return type, which is itself a higher kind of type. It's a type constructor. So in the case of return try, that is try of unknown thing. But it might be future of unknown thing, it might be option of unknown thing, or it might just be, in the case of the default, just a raw thing. Mm-hmm. Plus there's a method definition, which is the way, given a lambda, it's the way of creating an instance of the wrapping type. Mm-hmm. So in the case of return try, the wrap type is try of t. The method implementation is basically the same. It's try open parenthesis, then the lambda close parenthesis, because that will return something of the right type. And yeah, that's kind of it. It does use dependent method types. So this is dependent method types is a new feature in Scala. I think it was introduced in Scala 2.9 as experimental and became standard in 2.10. Whereby the return type of a method can depend on one of its parameters. So normally the return type is sort of a very general thing derived from the specification of the method, rather than the actual way it's applied. What we can do is we can have a method whose return type is dependent on the implicit parameter, the mode in this particular case. So it will look for the mode, it will describe the return type as being dependent on that mode parameter, even though it's not specified at the call site, it's derived implicitly. And we are able to talk about the return type of a particular fallible method as mode, it's lowercase m, mode, because it's a parameter name, dot wrap of JSON or whatever our method's meant to be returning. So that was a very I don't know if that was a useful explanation.
Yeah.
There's a lot of complicated stuff. It's a combination of three things. It's a combination of three advanced features: high kind of types, dependent method types, and implicits or type classes.
I understand a little.
Okay. See the afterwards, and I'll show you some sample code because it's not that complicated. It's just the fact it's combining these three really quite advanced features in a slightly complicated way.
Thanks.
Okay. Any other questions? Any questions about type level Scala? So I don't. Who knows about type level Scala? So I can tell you a bit about type level Scala because I've been involved with that. So Miles Sabin. Who knows Miles Sabin by reputation? Okay. So Miles developed Shapeless, and he was concerned that the rate of development of Scala was a bit slow. So the roadmap was published a couple of months ago, which had a lot of good features for things like interacting with Java 8, but didn't have a lot of new, advanced, and exciting features. It was very much focusing on TypeSafe's main domain, which is enterprise customers and the things they care about most. So Miles wanted more from it. He wanted to see new features coming faster, and he felt, and I agreed with him, and other people like Eric Osheim and Lars Hupel agreed as well, that we wanted to see a faster pace of development. We wanted new features sooner. And that was kind of a bit incompatible with what TypeSafe were doing. TypeSafe were building Scala that is very robust and it's something their customers can rely on as being stable, unlikely to change dramatically. They can invest money in Scala 2.10 or Scala 2.11 and know that it will be supported in the same form for several years to come. Now these two things are kind of at odds with each other. So Miles decided that it was a good idea to fork Scala. So we're branching type level Scala away from the main TypeSafe Scala, and we're going to add new features to it. We've already added a few new features already, and then some of these are quite exciting. So we've got things like type lambdas. If anyone's used Scala Z or Shapeless, type lambdas provide a very neat way of describing partial application on types, much more concise than you would get without this special syntax. So that's a new feature, which is kind of specialised. If you don't work with those, then you probably wouldn't appreciate it. There's a few other little things like being able to put a prime, like a quote, on the end of your identifiers. Small little changes like these that will be useful to hopefully lots of people, but wouldn't be the kind of things that would ever get into the mainline TypeSafe branch. So there's been a lot of activity over the last month or so since it was announced on type level Scala. I hope that maybe in a year or so we'll see type level Scala as a viable alternative to TypeSafe Scala. At the same time, we are working closely with TypeSafe. So some of the things that go into type level Scala will maybe make their way into TypeSafe Scala as well. Martin Odersky is very keen to see features moving between the two, but type level Scala is a more experimental branch. It's for people who are happier living on the bleeding edge and don't need the same kind of robustness and stability as enterprise users. So this is the situation. It's been going quite well so far. Type level Scala has been improving, and we're hoping to release binaries before the end of the year. So we're hoping to have our first release probably sometime in December, and hopefully that will be useful to people.
How will we use the tooling support in this case? Because
Right, so yeah, it's a good question, tooling support. So the tools that are maybe relevant are SBT. SBT will work with type level Scala, so it's possible for us to make SBT aware of type level Scala, so that will work just by specifying type level Scala as the Scala version. IDE support. Now this will work certainly with Eclipse, because Eclipse simply uses an underlying compiler to know what it has to do. But I guess a lot of you use IntelliJ. Yeah? I don't know how well that will work, and there might be some work for us to do in supporting type level Scala specifically in IntelliJ. So that's an unknown yet, but I mean many of the tools we've got already will happily work with type level Scala as well. The syntax so far hasn't changed too much. It's not diverged vastly from type safe Scala. And in fact, we have a requirement. There's quite a strict binary compatibility and source code requirement, which is that if you compile original Scala source code with type level Scala, it will work fine, provided you don't specify any flags. Now, new features which require some change in the syntax will require additional flags to be specified. So if you want to use the new advanced features, you can use them, but you have to be explicit about what you're using. So for now, this may not remain true in the future, but for now, if you want to use, for example, type lambdas, if you want to use primes at the end of identifiers, if you want to use, for example, currency symbols in your code, you need an additional flag, or you can import all the flags at once, and they're called Z flags. So in the same way that Scala C, you can call them -X and then some additional flag, or -Y. We've introduced -Z flags, and they will they sort of introduce these new features. So the compatibility thing is kind of important, because we want all the code we compile with type level Scala to remain compatible with type safe Scala. So if something is compiled with type level Scala, you can still access it from type safe Scala. That may not remain true if there are features that we're very eager to have, but there's just no way we can make them work with type safe Scala. Then we may have to compromise there. But for now, because we're concerned that we don't want to break up the community. The community is just getting started in many ways. We don't want to introduce confusion and compatibility problems and just add another difficulty to beginners who are learning Scala. So things will remain compatible.